first, let's save that to 9. We already have those bottom and surrounding. Side piece. We have this one. Already we have this one. We simply take advantage of this symmetry because we move that from the center to this some far away from the origin. Then we can make this rotate. Finally, so these are the final part. We take care of the inner geometry of pen holder. It consists of a hollow cylinder and 6 inner wall. So what we will do is we keep adding some more perimeter. One is the cylinder diameter. Let's see, that's a 50. Cylinder height is 100. Cylinder walls is 2. And we have this calculation here. So we will have inner wall, external wall. So here we have those hex height and hex radius. So let's copy this. We can define this here. And what we will do is some center cylinder. So first is the center cylinder. Second is the inner wall. So let's do this one by one. So from this wall, let's make the cube first. So this cube is we have using what we have calculated. Then we'll put in here. So let me F3, F5. So you have this wall here. So let's see this wall is here, and we need to move this to this position. So let's see the arrow. Hexagonal height was assigned on line 102. So this one height is already here. So I can just add this after and delete this one. Yeah, that's good. Then I can make this wall move. So translate. Translate how much is just go with the X, and some is Y. This cylinder DM. Let me see. Oh, double. Oh, so sorry. So I put here. Perfect. Now where it's moved to the right position, what we need is same as this one. The earlier one is we can make this rotate. Again, is this one. If we see it's also good is we put that into this one. Then we can make rotate just one time, because here, whenever you see our these repeatable things, let's try not to do this. So if I do this and putting that inside this border and put this as our inner wall. Then I don't need to draw this, I believe. But then is the interesting is we are now rotate to the different things. So it's coming to here. So that's the interesting part is when we rotate that, it's not rotate based on our expect things. So that is the you can consider is first we are putting this here. Let me just try to show you is here, and what we rotate. So rotate is from the 0.660. So that is from this rotate, but we did this translate here. So what we have done there is this translate. So I think is I should do another part. So I remove this. I don't touch this one. They can do the union themselves. And what I translate is I make another union here. And after this, I give our rotate. So if I don't have this one, you can see here, that is what I want. So this union means is I let this external frame and the bottom as one. They are doing the translate from here, and then my another wall. So this one is have the another translating ourselves, because I need to translate this, and another the other part is they build that and translate to not directly go to this X and Y. They go they make our turning. So that is the different the transformation. But from here, so what we are doing is we do the second union outside this two translation. That translate. Then after that, we are building. Let's see what we have here. Actually, they are not go to the same. So if we put this wall is come to here, then I think it will be easier that we can combine them. But since we already built this by the different parts, well, let's use this way, and we at least save for one duplicated rotate and for loop. So if you just have this 6 times loop is fine, but consider is if you want to do this every just every degree, that will be a huge change. So you can see here is getting the calculating, but imagine that you need to do the 2 times of this for loop, then that will be time consuming. So just my recommendation is whenever you see your opportunity to putting some code together and save transformation, try to do that. So what we left now is just our center cylinder. So center cylinder, nothing need to do as the transformation. So I just copy here because it's very easy. We just have our this cylinder. So if you see here, we have this cylinder, and what we do is we make our little translate, because we want them to go to height enough, and we have another cylinder. It's bigger, and using this bigger remove the inner side. So this difference is just very easy things like we did. Then we make this one. So and if we putting them together, so our cylinder is just exactly connect with our 6 wall. So that is our almost the final things. So you can download this one. So let me also save this to our model file. So here, go to the master and number 5. And you have this done, and if you want this, you can add some additional things like this. I want this old file number, face number is 100, so you can imagine that will be getting smoother. Or 500. See the difference. And if I put F5 and now F6, let me do this rendering now. I think this newer version is also getting faster, maybe better performance compared to the 2021. So this now is getting rendered. You can export this to our file, and if I push that to the GitHub, let's see. So in GitHub, come to code. Go to here, and you'll see this model file. So this model file now is able to print from your 3D printer. So you can see here, so good enough. But here I got our warning. So let's see. Object may not be a valid to manifold and may need repair. Exported object may not be a valid to manifold. So that is something I don't demo here, but you may face that is when you transfer this model to our real 3D printer. Then you also need to take care from that hardware. The printer side is some face connect each other, may have some the physical printing those issues which we should fix at that time. So, but here I think we already good enough to learn the way to do this model. So I don't take time for this the actual printer part, but you can try. I will also make some ideas to later on to send this to the printer and to have a look. What's that mean? Yeah, thank you for watching this project number 5. See you in the next project.